In section 1.7, we are going to look at linear inequalities and absolute value inequalities. We're first going to look at interval notation. We'll define what that is. Then we'll look at intersections and unions of intervals. Then we'll solve linear inequalities. And then we'll recognize an inequality that does not have a solution, or all real numbers are a solution. We'll talk about compound inequalities, and then last but not least, we'll solve absolute value inequalities. Suppose you want to go on a vacation and you want to rent a car. So you're going to rent a car from Rent-A-Heap. The car is going to cost you a flat fee of $125 per week. You're also going to get charged for every mile you drive the car, and you're going to get charged 20 cents for every mile. Now let's suppose also that you're on a budget. You can spend at most $335 for renting this car. That's the most you can spend. Let's let X represent the number of miles you drive the car. So what is this going to cost you? It's going to cost you the flat fee of $125 plus 20 cents for every mile you drive it. So 0.20 times X. Now, at most, I can spend $335. I can't spend $335.10. The most I can spend is $335. So I represent this using an inequality symbol. The amount I spend renting this car has to be less than or equal to $335. And that's what this symbol means. Less than or equal to. You could spend less than $335. You could spend exactly $335, but you can't spend more. So solving an inequality, placing an inequality symbol between a polynomial of degree 1, that means it's a linear polynomial, and a constant results in a linear inequality in one variable. So in this section, we're going to learn how to solve the inequality that we got from the previous slide on renting this car. The 125 plus 0.2x is less than or equal to 335. And then we're going to learn how to write that in interval notation and how to graph it. Solving an inequality is the process of finding the set of numbers that make the inequality a true statement. These numbers are called solutions of the inequality, and we say that they satisfy the inequality. The set of all solutions is called the solution set of the inequality. So let's take a look at some linear inequalities. The first linear inequality we have here is x is greater than 4. That is a linear inequality because the exponent on the x is the number 1. What's that mean? X represents any number larger than 4. What numbers are larger than 4? There are a lot of numbers larger than 4. 5 is larger than 4. 6 is larger than 4. 4.005 is larger than 4. So how do we represent this graphically? So what we do is we draw an open circle at the 4, and we draw an open circle because we do not have equality. We have x is greater than, not x is greater than or equal to. So since we don't have equality, we don't include 4 in this set. So we draw it with an open circle at 4. And then we draw an arrow to the right. So that graphically represents all the numbers greater than 4. Now, in algebra, we typically don't draw this graph with an open circle. We use a parenthesis. So we draw a parenthesis at 4, and then a line with an arrow to the right. So what does that line with the arrow to the right mean? It means that we could continue on to infinity and those numbers will still be larger than 4. So any number to the right of 4 is larger than 4, greater than 4. So we have a notation that we use to write this kind of set. We call it interval notation. The interval of numbers that satisfy the inequality x is greater than 4 starts at 4. Where does it end? Well, it doesn't. You can continue to the right forevermore. So the way we write this is we put our 4 and we put a parenthesis next to it. The parenthesis next to the 4 simply indicates that 4 is not included. We don't have equality. Then we put a comma, and then we use the infinity symbol. And we close it with a parenthesis. So when you see this kind of notation, this means the interval of numbers between 4 and infinity. Infinity is not a number, it's a concept. So this simply means that all the numbers to the right of 4 satisfy this inequality. All right, so let's look at the next one. The next one says that x is less than 5. So normally we'd draw this, we'd graph this with a circle at 5, and less than means all the numbers to the left. So we would draw a line with an arrow to the left. Now in algebra, we typically don't use the open circle graph. Again, we're going to use a parenthesis. And the parenthesis indicates that the 5 is not included in this interval of numbers. Any number smaller than 5 satisfies this inequality. 5 is not smaller than 5, 5 is 5. So we use a parenthesis to indicate that 5 is not included. Now how do we write this in this interval notation that we have? Well, where does this interval start? Well, this interval continues to the left forever. So it starts at negative infinity. Now again, negative infinity is not a number, it's the concept. So the concept is it starts to the farthest left that it can be. And we're going to represent that as negative infinity. We're going to put a comma, and then we're going to put the 5, and we're going to put parentheses. A couple of notes here. You always have a parenthesis next to an infinity symbol. Always a parenthesis because we never reach infinity. Infinity is a concept that simply means we continue on forever. Okay, now what about the next one? X is greater than or equal to negative 3. Now, if we were to graph this, what we normally would do is we would put a closed dot at negative 3. That means negative 3 is included in the solution set of this inequality. In other words, any number negative 3 or greater would satisfy this inequality. So negative 3 satisfies it. Negative 3 is greater than or equal to negative 3. Negative 2 would satisfy it. Negative 2 is greater than or equal to negative 3. So any number to the right of negative 3 will satisfy this. So we draw a line with an arrow to the right. Now, what does our interval notation look like? How would we write this as an interval? Well, this interval starts at negative 3. And it continues on to the right forever. So it's infinity. We always use a parenthesis next to infinity because infinity is a concept, not a number. So you can't actually ever reach infinity. But at negative 3, we're going to use a bracket. And that's how we would graph it. We would graph it using a bracket and an arrow to the right. The bracket indicates that the negative 3 is included in the solution of that inequality. So negative 3 does satisfy that inequality. So if we have equals in our inequality symbol, we use a bracket. If we don't have an equality included in our inequality, we use a parenthesis. So a parenthesis if you have less than or greater than, A bracket if you have less than or equal to or greater than or equal to. So if you have equals, equality, you use a bracket. So what would we do with the next one? Well, it's all the numbers less than or equal to 0. So close dot, all the numbers to the left. Or in our bracket notation, it's a bracket and an arrow drawn to the left. So what does our interval notation look like? Well, this interval starts at negative infinity. We always use a parenthesis, never a bracket next to infinity, comma 0 with a bracket. So if we have equality, use a bracket. If we don't, we use a parenthesis. All right, what if we have this type of inequality? How is this read? Let's read the first one. The first one is read, x is greater than negative 5. X is greater than negative 5. And x is less than 4. So this is read, x is greater than 5, negative 5, and less than 4. So what's that mean? That means all the numbers between negative 5 and 4. So if we were to draw this using circles, we would have a circle at negative 5 and 4, and then we would draw a line of all the numbers in between. Using parentheses, it would look like this. Parenthesis, line 2, 4. So a parenthesis at negative 5, a parenthesis at 4, and a line showing all the numbers in between. So how do we write this in interval notation? We're going to write this as parenthesis, negative 5, comma, 4. So this is why the context of your symbology is important. Back in section 1.1, if we wrote parenthesis negative 5 comma 4 parenthesis, that meant a point on the coordinate plane. We went 5 to the left and 4 up, and we plotted a point. So in the context of ordered pairs, that's a point in the second quadrant on the coordinate plane. But that's not what we're talking about. We're talking about inequalities. So in the context of inequalities, that is the interval that starts at negative 5, not including negative 5, and ends at 4, not including 4. So it's in all the numbers from negative 5 to 4, not including negative 5 or 4. All right, how do we read the next inequality? This is read, x is greater than or equal to, so you see we have equality there. X is greater than or equal to 3, and x is less than or equal to 5. So what's this? How do we draw this? Well, since we have equality, we would draw at 3 a solid dot, and at 5 a solid dot, and then all the numbers in between. So using our bracket notation, we would use brackets. Brackets again tell you that you have equality. The number is included in the solution to the inequality. So how would we write that? We would write that as 3, comma 5 with brackets around it, because we have equality on the 3 and the 5. So both of those numbers are included in this interval. All right, so let's summarize all this. So let's talk about interval notation. So if I have two real numbers, A and B, and A is less than B, the open interval, parenthesis A comma B, represents the set of real numbers between but not including A and B. So parenthesis A comma B is equal to, this is read, this is set builder notation here, it's read, the set of all x such that x is greater than A and less than B. So it's all the numbers in between A and B, not including A and not including B. So graphing it, we would draw a parenthesis at A, a parenthesis at B, and draw a line between those two numbers. The closed interval, by the way, I should have said that's called the open interval. It's called an open interval because you could draw it with open dots at each end. So it's open. Neither endpoint is included in the interval. So it's an open interval. The closed interval, bracket A, comma, B, bracket, represents the set of real numbers between and including A and B. So A and B are included in the interval. So bracket A, comma, B, bracket is read, the set of all x such that x is greater than or equal to A and less than or equal to B. So the way you would graph this is you would have a bracket at A, a bracket at B, and you draw a line in between those numbers. So it's all the numbers between A and B, including A and B. A and B are included in the interval. The next two intervals are called infinite intervals, and they're infinite intervals because they continue on forever. The first infinite interval is parenthesis A, comma, infinity. This represents all the numbers larger than A, all the numbers greater than A. So parenthesis A, comma, infinity equals the set of all x such that x is greater than A. So if we start at A and we continue to the right forever, that's all the numbers greater than A. To graph this, we put a parenthesis at A and then draw a line to the right. The next infinite interval is negative infinity, comma, B bracket. And we're just showing you the difference between using a parenthesis and a bracket. You could also have this interval where you would have a parenthesis on the B. The same is true for the previous infinite interval. You could have bracket A, comma, infinity. That simply means that point is included in the interval. All right, so we have negative infinity, comma, B with a bracket on the B. That is the set of all x such that x is less than or equal to B. Since we start at negative infinity and we end at B, that means that's all the numbers to the left of B on the number line. So to graph this, we would put a bracket at B and draw a line to the left with an arrow on it. Again, parenthesis, the number is not included in the interval. Bracket, the number is included on the interval. Now you think I'm bugging you about that, but you'll forget it. Parenthesis, number not included. Bracket, number included. Never a bracket on infinity. The open interval AB represents the set of all real numbers between but not including A and B. The closed interval, bracket A, comma, B, bracket, represents the set of all real numbers between and including A and B. So bracket, you include the point in the interval, parenthesis, you do not. The two infinite intervals, A, comma, infinity, means all the numbers greater than A. The other infinite interval, negative infinity, B, bracket, means all the numbers less than or equal to B. Parentheses indicate endpoints that are not included in an interval. Brackets indicate endpoints that are included in an interval. You always use parentheses with infinity or negative infinity, never a bracket. Okay, here is the summary of all the different types of intervals that you have. The first open interval that we talked about a minute ago. AB, the closed interval, all the numbers between A and B, including A and B. The next interval is called half open because you have a bracket on one endpoint and a parenthesis on the other. So you have a closed dot on one end and an open dot on the other. So it's half open. The next interval, parenthesis A, comma, B, bracket, is also a half open interval. It's open on the A end but closed on the B end. And then you have your infinite intervals, A comma infinity, where you have parentheses on both, A is not included. Bracket A comma infinity, A is included in that interval. And then you have the two intervals from negative infinity to B. That is the infinite interval where all the numbers are less than B. Negative infinity comma B bracket, all the numbers less than or equal to B. And then the last interval from negative infinity to positive infinity, that interval indicates all real numbers. So whenever parenthesis, negative infinity, comma, parenthesis, close parentheses, that means all real numbers. Everything on the number line from negative infinity to positive infinity. All right, so let's see if we can't use our interval notation. We're going to graph this and we're going to write set builder notation. And it doesn't really matter what order we do this in. So we have bracket 1, comma, 3.5 bracket. So that is the closed interval from 1 to 3.5. So I would put a bracket at 1, a bracket at 3.5, and it's all the numbers in between. In set builder notation, we would write this as the set of all the x's such that, well, it's all the numbers in between 1 and 3.5. So we would say x is greater than and equal to 1 and less than or equal to 3.5. So it's the set of all x such that x is greater than or equal to 1 and it's less than or equal to 3.5. The next interval from negative infinity to negative 1 with the parenthesis on the negative 1. This means all the numbers to the left of negative 1, all the numbers less than negative 1. Since it starts at negative infinity, the concept that it starts at negative infinity, and ends at negative 1, that's all the numbers to the left of negative 1 on the number line. So we would draw a parenthesis at negative 1 and an arrow to the left. All right, set builder notation. This would be the set of all x such that x is less than negative 1. All right, let's talk about intersections and unions. Graph to find the intersection or union of two sets given to you in interval notation. You first graph each interval on the number line. To find the intersection, you take the portion of the number line that the two graphs have in common, where the graphs overlap. To find the union, you take the portion of the number line representing the total collection of numbers in the two graphs. So you join them together. An intersection is what they have in common. A union is all of them together. So let's graph the intersection. That's what that symbol means. The upside down union, U symbol, I can't say that. The upside down U means intersection. So we're going to find the intersection of the sets from 1 to 3, the interval from 1 to 3, with the interval from 2 to 6. And I'm going to draw these in different colors just so that we can get an idea of what happens. Okay, so I'm going to draw my first set in blue. So I'm going to draw the set, the interval from 1 to 3 in blue. So I would put a bracket at 1, a bracket at 3, and then I'm going to draw a line in between. The next interval, let's draw that in orange. So we're going to draw the interval from 2 to 6 in orange. So we're going to start at 2, we're going to end at 6, and everything in between. Now the intersection of these two sets is where these two sets overlap. And where do they overlap? They overlap from here to here, so from 2 to 3. But on the 2, we have a parenthesis, and on the 3, we have a bracket. So we're going to write that set as parenthesis 2, comma 3, bracket. So the intersection of those two sets are the numbers from 2 to 3, not including 2, but including 3. This set is called half open because we're not including the 2, but we are including the 3. All right, let's look at a union. That's what that symbol means. That symbol means union. All right, so we're going to first graph the two intervals. So we're going to graph from 1 to 4. Let's do that in blue again. 1 to 4. And then we're going to graph from 2 to 7. We'll do that in orange again. From 2 to 7. All right, what's the union of these two sets? Well, the union is everything. We're going to join the two together. So where does this, once we've drawn this, where does our drawing start? Our drawing starts at 1, and our drawing ends at 7. So the union is the interval starting at 1 and ending at 7. So the union is from 1 to 7. Now I have a parenthesis at the 1 and a bracket at the 7, so it's parenthesis 1, comma 7. So an intersection is where the two sets overlap. The union is when you join the two sets, two intervals together. All right, let's talk about solving inequalities. So would you agree that this inequality is true? 2 is less than 7. 2 is to the left of 7 on the number line. All right, what if I add 2 to both sides of this inequality? So let's do that. So I added 2 to both sides. So I get 4 is less than 9. This is true. So what this is called inductive reasoning. We're showing it's true to get to a specific point. So we're showing it true for an example. And that's true. It worked. And as a matter of fact, I could add anything I want to on both sides of an inequality, and the inequality would remain true. What if I subtract? Let's subtract 2. That's true. 0 is less than 5. So as a matter of fact, I can add or subtract anything I want from both sides of an inequality, and it remains true. Anything. Absolutely anything. All right, let's try multiplication. Let's multiply by 2. So I have 2 times 2 less than 7 times 2. Is that true? 4 less than 14. So that is true. So it seems like I can multiply both sides of an inequality by a constant and it remains true. But what happens if we multiply by -2? So I have 2 times -2 less than 7 times -2. So I have -4 is less than -14. That is false. -4 is greater than -14. -4 lies to the right of -14 on the number line. -14 is farther left than -4, however you want to think about it. That is false. That is not true. So how do we take care of this? What do? We flip the inequality around. So what can you do to solve linear inequalities? You can add or subtract anything you want from both sides of an inequality and it remains true. You can multiply or divide both sides of an inequality by any number that's positive and the inequality remains true. If you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol. You have to flip it around. A linear inequality in x can be written in one of the following forms. Ax plus b is less than 0. Ax plus b is greater than 0. Ax plus b is less than or equal to 0. Or ax plus b is greater than or equal to 0. And in general, when we multiply or divide both sides of an inequality by a negative number, the direction of the inequality symbol is reversed. You flip it around. So here are the properties. The addition property, you can add or subtract anything you want from both sides of the equation, of the inequality, and it remains true. The positive multiplication property, you can multiply or divide both sides of an inequality by any value that's positive and the inequality remains true. However, if you multiply or divide both sides of an inequality by a negative, you must reverse the inequality symbol. Let's solve an inequality. We're going to solve it. We're going to write it in interval notation, and we're going to graph it. So I have 2 minus 3x is less than or equal to 5. And I pretty much solved this just like I would solve a linear equation. The only thing I have to remember is if I multiply or divide both sides by a negative, I have to reverse the inequality symbol. So if this were an equation, I would subtract 2 from both sides. If this were an equation, I'd divide both sides by -3. And as soon as I divide by a negative, I go down there and I turn my inequality symbol around. So what do we have? X is greater than or equal to -1. And it's greater than or equal to, the arrow points to the smaller number, or it opens to the bigger number. So this is red. X is greater than or equal to -1. So what's that mean? It means all the numbers to the right of -1 on the number line, including -1. We would use a bracket. So it's all the numbers to the right of -1. Any number that's bigger than -1 makes this inequality true. Any number that's less than -1 would make this inequality false. Okay, so the solution in interval notation, if we start at -1 and we continue to the right to forever, then our interval would be from -1 to infinity. In set builder notation, this would be the set of all x such that x is greater than or equal to -1. All right, let's solve this inequality. This inequality contains some parentheses, so I do need to remove those before I solve it. So I'm going to distribute the 3 across. And I have 3x plus 3 is greater than 3x plus 2. I might subtract 3x from both sides, and I end up with something. 3 is greater than 2. Yeah, it is. 3 is greater than 2. So what's this mean? This means that it doesn't matter what you plug in for x, it'll work. You can put any real number you want in for x, and the inequality will be true. So if you're solving an inequality and you end up with a statement that's just true, then the solution set is the set of all real numbers. Because any real number will work. Now, the way we write this in interval notation is we say all the numbers from negative infinity to positive infinity. So all the numbers on the number line. All right. Now I should go back and say that if you're solving an inequality and you end up with something that's inherently not true, so let's say, for instance, you came up with the opposite, something like that. If you end up with something that's not true, then there's no value for x that you can substitute in, and it will work. So in this case, there's no solution. Or the solution is the empty set. All right, let's solve this compound inequality. This is called a compound inequality because our variable is between two numbers. And you can solve this by separating this into two inequalities and then putting it back. So this is true. I just think that's probably more work than I need to go through. So I solve a compound inequality just like I solve any linear inequality. I'm going to isolate the x on the in the middle of these two inequality symbols. So I want to get the x all by itself. And to do that, I'm going to subtract 3. Well, whatever I do to the middle, I have to do to the two endpoints. And then I'm going to divide by 2 to isolate the x. So I get x is greater than or equal to -1 and less than 4. So in set builder notation, it's set of all x such that x is greater than or equal to -1 and less than 4. Erase that. Okay. All right, the graph, what's the graph look like? Well, we would have a bracket of at -1, a parenthesis at 4, all the numbers in between. So interval notation would be from -1 to 4. We have a bracket on the -1 because we have equality on the -1 side. We have a parenthesis on the 4 because we do not have equality. So 4 is not included, -1 is included in the solution. All right, absolute values. You know that the symbol straight line, x straight line, describes absolute value, and absolute value is defined to be the distance that number is from 0 on the number line. So we can use this geometric interpretation to solve an inequality such as the absolute value of x is less than 2. So what's that mean? That is read that the distance, some number x, is from 0 is less than 2. So where on the number line is the distance from 0 less than 2? Well, between -2 and +2. That's the only interval over which the distance from 0 is smaller than 2. If you're to the left of that interval or to the right of that interval, the distance from 0 is larger than 2. So the solution to the inequality, the absolute value of x is less than 2, is the interval of numbers between -2 and +2. Or x has to be greater than -2 and less than +2. That's the only place on the number line that the distance from 0 will be less than 2. What if we have the absolute value of x is greater than 2? This means that the distance, this number x, is from 0 on the number line is bigger than 2. Where would that be? Well, it's certainly not between -2 and +2. We know that between -2 and +2, the distance is less than 2. So where is the distance greater than 2? Well, to the left of -2, but also to the right of +2. So anywhere to the left of -2 and to the right of +2, the distance you are from 0 on the number line is greater than 2. So the way we write this is, it's the set from -infinity to -2, that's this part of the graph, union with, so we put a union symbol in there. The other part of the graph is from 2 to infinity. So we union -infinity to -2 with 2 to infinity. In set builder notation, that is the set of all x such that x is less than -2 to the left of -2, or it's greater than +2 to the right. So this says x is less than -2. Remember, the arrow points to the less. X is less than -2, or to the left of -2, or x is greater than 2, to the right of 2. Okay, so let's give you some formulas. Remember, in algebra, anytime you see the variable u, that can be replaced by an algebraic expression. So u represents some algebraic expression. What's an algebraic expression again? It's a combination of variables and constants using addition, subtraction, multiplication, and division. So if u is an algebraic expression and c is a positive number, the solution of the inequality, the absolute value of u is less than c, may be found by taking the expression u and setting it greater than the negative and less than the positive. So you put the expression u in between -c and +c. That's how you solve a less than type absolute value inequality. What if it's greater than? If I have the inequality, the absolute value of the expression u is greater than a positive constant c, to solve that inequality, I take the expression u, I set it less than the negative constant and greater than the positive constant. There is no other way to do this. I've seen some creative methods, but there is no other way to do this. You take the expression inside the absolute values, so you remove the absolute values, you take the expression inside the absolute values, you set it less than the negative constant. You take the expression inside the absolute values, so you get rid of them, and you set it greater than the positive constant. You can replace less than and greater than with less than or equal to, or greater than or equal to. There is no other way to solve this. Are you listening? To solve a greater than type absolute value inequality, you take the expressions inside the absolute value bars. It can be less than the negative constant. You take the expression inside the absolute value bars. It can be greater than the positive constant. So solve 18 is less than the absolute value of 6 minus 3x. This is a greater than type absolute value inequality, because I could rewrite this as 6 minus 3x. The absolute value of 6 minus 3x is less than excuse me, I'll spit it out. The absolute value of 6 minus 3x is greater than 18. All right, how do you solve this? You take the stuff that's inside the absolute value bars. Okay, so what's inside the absolute value bars? 6 minus 3x. You're going to take that and you're going to set it less than the negative constant. Less than negative 18. Then you're going to set it greater than the positive. So where is the distance? Because that's what that means. The distance is greater than 18. Where is the distance greater than 18? Well, to the left of negative 18 or to the right of positive 18. Now you solve the resulting linear inequalities. So I'm going to subtract 6 from both sides. I'm going to divide both sides by negative 3, and I note that I do need to reverse the inequality symbol because I'm dividing by a negative. So I get x is greater than 8. Let's write that over here. Now I'm going to solve the other one. I'm going to subtract 6. Divide by negative 3. And I note that I do need to reverse that inequality symbol. So I get x is less than negative 4. Okay, if I draw this on the number line, oh, I don't have an 8 on here. It's everything to the right of 8 and everything to the left of negative 4. So in interval notation, that would be from negative infinity to negative 4, unioned with from 8 to infinity. There is no other way to do this. I've seen some creative ways, but what you do is you take the expression on the inside of the absolute values, you set it less than the negative constant and greater than the positive constant, and then solve the resulting inequalities. And you will get a union of two sets. So you'll have one going to one direction, the other going the other direction, and you'll union them together.